Okay. Okay, type yes in your chat box if you can hear me. I can see Shekhar, Soumyadeep, Sai Prakash. Okay. Shall we wait for 2 minutes? Yes or no? I think people are still joining. Okay, I think good enough. See, what I have planned is my name is Srinivas Bhaskara from Indian Institute of Science, and my plan is like what are all like we may have 12 to 14 hours of discussion among each other. So what we can do is I'll try to get miscellaneous problems that were asked in GATE or other exams and all those things, and then we will try to solve those problems, and then we can continue our discussion. What do you guys think? Is that okay? Or you have any specific topics that you want me to teach? I can teach you in one of the sessions. But of course, during the problem solving also, I can teach the same thing. Okay. All right. So what we can do is, are you guys ready with pen and paper? Because I will be showing you kind of problems, and then you need to solve, and then whenever you get the answer, you reply in your chat box. Right? So based on the response, whether it is right or not, something like that. If you have any questions, any doubts, we can start solving one by one. And then, if required, I can also teach the concept parallel, if possible. That is required. Right? Good. Okay. Can you guys see my screen? Can somebody just unmute yourself and then talk? Okay. It's maybe I cannot see the chat once I start sharing it. Can somebody tell me? You can unmute yourself and then say. Okay, I will call out the name. Sangesh, can you able to see my screen? Okay, come on, you need to unmute and then talk, no? If I ask you, are you are such a cruel people, huh? Okay, all right. Okay, here comes the first question. See, now I am in a full screen mode. I may not be able to see your answers. If you have any questions, right, I would like, if you have any questions, you can unmute yourself and then talk. Similarly, if you have answers, you can unmute yourself and then talk. No problem. Let's have an interaction. This is live mentoring interaction, right? All right. So this is the first question. So what it says is very simple. Uh, number of literals and variables in the simplified form of f xy plus yzw plus zx bar is dash. I'll give you just 2 minutes. Let's take 2 minutes time. Try to solve it. Meanwhile, I'll check if somebody is waiting in the meeting room. Oh, I have to enable everybody. So number of literals and variables in the simplified form of f, where f is xy plus yzw plus zx bar is dash. Okay. Any answers? In the chat box, I can see Akanksha said C. Rajesh is saying B. Okay. I think better I'll switch from there to here now. Yeah. Okay. Okay. Can I solve the problem? Okay. Thank you. So, for examples, let's say you have a function f of a, b, c. For example, is given, right? We know already what are the variables. F is a function of a, b, c. Now, how many variables are there? Three variables. Okay, we can say clearly that f is a function of three variables, right? Now, if it comes to literals, a is a literal, a bar is a literal, b is a literal, b bar is a literal, c is a literal, c bar is a literal, means you have a possibility of having 6 literals, right? Now, keeping that in mind, let's solve this. xy plus yzw plus zx bar, right? This is the problem that is given. See, there is a, see, now if it looks like, as if you look at this as it looks like you are not able to solve anything. Correct? You know that if there is something clearly a plus a bar is equal to 1, b plus b bar equal to 1, a into a bar is 0, all these kind of identities and all looks like that, right? Where nothing is possible in F. So there is something called consensus theorem. Consensus theorem. See, what is that you are supposed to do is, once you solve everything, once you simplify everything, finally everyone has to check with the consensus theorem whether I can apply consensus theorem or not. Once you apply consensus theorem, then only you have to talk about the final simplified form. So what is consensus theorem says is very simple. You know, yeah, I'm coming to the point only. I'm not saying that you will apply directly, right? Just see, no problem. Just wait for 2-3 minutes, you'll understand why I'm saying that. You have something called a p1 plus a bar p2 plus p1 p2 we know that this is equal to AP1 plus A bar P2, right? Don't ask me proof and all those things. This is already available in many of the standard books. It's very easy also. I think one of the KMAP lectures and all, I will just see that. Now also I can do it, but still, it's the first session, so let's not discuss that. Now, if you have this form, AP1 plus A bar P2 plus P1 P2, something like this, you can convert this as this. Means this is the simplified form, right? Now, what somebody spoke right now, what she is saying, sir, it's not looks like in that format. Yes, you are absolutely right. But let me decode little bit in this. Let me write this. This is xy, right? Plus, this is I can write as x bar z, the second term. This is, let's say, first term. This is the second term. Okay. I am trying to figure out this kind of particular term, like AP1 plus A bar P2. Plus, you have a third term here, right? Y, Z, W. Now, if you look at this fundamentally, it looks like you cannot apply consensus theorem because, sir, here only P1 is what? Y. Okay, let me take red. P1 is Y, like this is P2, and I should get P1, P2, right? P1, P2, I got what something else is there. That's what the doubt is. That's your absolute right. Now I can play a trick here. What is the trick here is, see this xy, okay, let me write like this, xy plus x bar z, okay, something like this, right? AP1 plus A bar. Can I write like this, xy plus x bar z plus yz? Now I'll put, instead of this, I'll put this here, xy plus x bar z plus yz. Instead of this, I'll write this plus yzw. Why? Because I can use this identity, no? Now what I can do is xy plus x bar z, you leave it. I can write yz. In these two, I can take yz common. 1 plus w. What is 1 plus w? Obviously, anything plus 1 is 1, right? I mean r, right? This is r operation. It is not plus or something. It should be r, but we just conventionally will talk like that. So this is 1. Now xy plus x bar z plus yz. Now is it in the perfect consensus form? Yes. So this can be written as what? xy plus x bar z. So this I can simplify to xy plus x bar z. Now, sorry, I'll write xy plus x bar z. Somebody tell me how many variables are there in this f? X is there, y is there, z is there. So what is the question? See, this is the trick thing. They asked literals first, variables later. Let's count literals. Okay, let me write literals. X is a literal, y is a literal, x bar is a literal, z is a literal. How many literals? 4. 4 literals are there. 3 variables are there. So option B is right answer. Are you guys clear? Okay. Okay. You can ask me any question if you have. I'll give you 30 seconds pause now for every problem. I'll give 30 seconds, 40 seconds pause so that you can ask. People can digest and then ask. Rajesh Kumar Roy has got right answer. Very nice. See, don't worry if you don't get the answer right, okay? This is how we can learn, right? That's why these sessions are. Okay, ready for second question? Is somebody asking for my permission to join? Oh, okay, all right. Okay, here is your second question. Oh, sorry. The Boolean expression for the shaded area. How can you interpret the Boolean expression for this? Shaded area means this red color thing, wherever I have shaded this. If you want to type it in the answers, I suggest you guys to unmute yourself and then talk. Of course, if there is a noise and all, I understand. You can just type it in your chat box, whatever is comfortable for you. But I prefer talking. Okay. Oh, sorry guys, I have to admit this. Hey guys, join as soon as possible. Otherwise, I will not admit you from next time. Sharp, maximum 5 2. Option A. Okay, somebody said option A. Very nice. Let's see. Any other options? Okay, all right. See, this interpretation, see, this is, I find this problem is very interesting. So I just took it. See, if you look at this interpretation, right? Now, there is something called A, correct? This is A completely. What is outside of this space? What is outside of this? Let's say I'll take this. Can somebody tell me what I should interpret? This is A. Red color is A, for example. In terms of A, can I write anything outside? Means, yeah, we'll come there. Okay. This is, like I can say, not A. It's like that is mine, this is not mine. It's like that, okay? That is A, this is not A. Okay. So, not A, in algebra wise, like Boolean algebra, you can write A bar. Okay. Similarly, think like that. Now you see this shaded area. This area, what is this area? Belongs to A. But if I say belongs to A, this also will come. Entire other areas will also come. So that belongs to A and not belongs to B and C, correct? Right? That belongs to A but not belongs to A, B and C. I can write this as what? A and not in B and not in C. And of all these things is this area. Agree or don't agree? Any questions? Agree, right? Now you look at this area. This is first area, second area. Now you have to talk about both the areas, right? So R operation. This is R operation plus second area is what? This is part of B and C. This everybody knows. It's the intersection of B and C. And also this part is not in A, right? This is not in A. A bar. A bar and B and C. So what is the right answer? A, B bar, C bar, A bar, B, C. Option A is the right answer. Which one, sir? Which one? Area 1. Where, for second area or first area? C. Okay. Why C? Why do you think C bar? It is part of C only, no? C. If I say B, this is C, correct? This combination, right? This is B and C, no? Correct? This is part of B and C only, no? Why C bar should be there? Part of C also, no? See this. That area 2, does area 2 exist in C or no? Does this exist in B? Yes. Does this exist in A? No. That's why A bar. Correct? Clear? Okay. Okay, hey guys, I'm just giving a reminder again. Join by 5 to maximum. After that, I will not allow anyone. Okay? Are you guys clear about this? Am I very strict? Very strict, huh? Hey, come on. I cannot go here and there and all, no? So, sorry. I'm also. Of course, you can call me Srinivas also. No need to say sir, right? So the point is that doesn't give an excuse to join it late, right? Okay, all right. So let's go to third problem. But I can give maximum one more minute. Okay, 5, 3, 5. Is somebody writing something? Okay, all right. Ah, so the question is in the Boolean expression AB plus A bar C plus BC plus ABC, which one of the following is true? Redundant prime implicants. They are saying whether AB and A bar C are redundant. Then ABC is non-prime, BC is RPI. I'll do one thing, okay? This I think we will discuss in the K-maps thing because it will be very easy for you. This is like now I have to explain everything again. Let's go to this problem. So number of minterms after minimizing the following Boolean expression. Actually, this is very straightforward approach. Very easy also. Anybody got the answer? Mesh Kumar said it is C. Option Mallesh said it is A. Okay, 3 minutes. Okay. No, no problem, no problem. We'll see that. Okay, great. Okay, somebody, what is this? A, C. Okay, Somebody said A, somebody said C. Nice. Right. So let's solve this. Now we know already this one, right? Once you look, this is the entire whole complement is there. These two, if you look at it, this is C bar D common from there. If I take the common, this is A plus A bar. We already see this is 1, right? D bar plus AB bar plus A bar C plus C bar D. And there is a whole complement, right? Now what I can do? I can work around these two, right? Because here D bar is there, here it is C bar D, right? So D bar, what I can write? D bar plus DC bar I can write. I can write this one as D bar plus D into D bar plus C bar. Correct, no? You know this law, right? Distributive law. A plus C. We have another distributive law, right? A into B plus C is A into B plus A into C. This is there, this is also there. Again, D bar plus D is 1. What will you get? D bar plus C bar. From these two terms, you will get D bar plus C bar. So now what are left with? A B bar plus A bar C plus D bar plus C bar. Now you can take these two. Similarly, A B bar. I'll put the complement later. Okay, let me keep it home. Plus C bar plus A bar. Correct? Plus D bar whole complement. Now A bar is there. Here it is. So A bar plus B bar plus C bar plus D bar. I know I'm solving little, I know, faster, but understand that this I am assuming that this everybody knows those laws and all. So now you can apply De Morgan's, right? A bar whole complement and B bar whole complement and C bar whole complement and D bar whole complement, right? What is this? A, B, C, D. This is min term 15, right? If it is a function of A, B, C, D, right? So how many midterms? 1 midterm. So option A is the right answer. Let me know if you have any questions. Okay, next question. Yes, somebody saying something? Clear? Okay, thank you, boss. Next. Solve this. Very nice question. I like this. Which of the following is true for Boolean algebra and not valid for ordinary algebra? A plus B equal to B plus A into B plus C. Just now we discussed this, right? Okay. Option C. Okay, any other people want to attempt? Okay, let's discuss like this. This you are clear about, right? It is valid for both Boolean and ordinary, right? Valid for both. This we are very clear. This is also valid for Boolean. See, if you are not clear, take some numbers, A equal to 1, B equal to -2, and do this, and C equal to 3, something like that, whatever the number you want to take. And this also we know. A into B equal to B into A. That's also, both it is valid. This is by default, it is going to be a culprit. And if you apply these numbers, right? So if I take 1 plus minus 2 into 3, this will be 1 minus 6 is nothing but minus 5, right? And let's see whether it is equal to that or not. A plus B is 1 minus 2 into what is A plus C? 1 plus 3. This is minus 1 into 4 is equal to minus 4. Is minus 5 equal to minus 4? No. So this is not valid for ordinary algebra. But this is valid for Boolean algebra. Can somebody tell me what is the proof? How to prove it? Sorry. Okay. You know about duality theorem? Right? So, duality theorem, I'll just give a glimpse of it. If somebody doesn't know, they will know this. We know that A into 0 is 0, right? A into 1 is 1. A and 1 actually. And A plus 0 is A, correct? A plus 1 is 1. Now, I already wrote the duality theorem over there. What you can do is, if there is a Boolean function f, and you say that G is dual to f. G, if you say that there is some function G, and you say that that is dual to f. That means that wherever AND operation is there, you replace with OR operation. Wherever OR operation is there, you replace with AND operation. Wherever 0 is there, you replace with 1. Wherever 1 is there, you replace with 0. Now, proof for duality, already I wrote it here. You see this? I'll take this. A and 0 is 0. According to duality, what you should do? A instead of AND, OR instead of 0, 1 instead of 0, 1. See this? These two are dual, right? Similarly, one can see this also. They are dual. So what is the use, sir? What is the use of this? Very simple. If you know one, see, you know that this is true. You automatically know this is true. That means that 50% of your effort is reduced. You don't need to prove it again and again. Right? So in mathematics, I'm saying. So similarly, I'll just erase this part. Now it is very clear, right? If I know that this is true, A into B plus C, this is distributive, right? And is distributive over R. A and C. I can also apply the dual to this. What is that I should do? A plus, this is B and C. Wherever dot is there and wherever and is there dot. I mean R. A plus C. If this is true, this will be automatically true. Sir, if this also doesn't go to your head, I recommend you don't by heart anything. I don't by heart anything also in this digital circuits. You take a truth table and then do it. You have 3-4 minutes time for every question in the gate. You take truth table, you take A, B and C, you take A plus B, A plus C, do the AND operation, and eventually you will make sure that this is true. And you don't need to do all those things if once you know that it's reality. Right? Shall I move to next problem? Say yes or no, type. At least type. I'm seeing it. Okay, all right. Solve this problem. So the problem is Boolean function AB plus A bar C is written as this. Which one of the following is true? There I saying M is equal to B, N equal to C, M is B bar, N is C, N is C, N is B, M is B, N is C bar. So while you're solving, I wanted to say something like we have different topics in digital, right? We have Boolean algebra, number systems. We may see this Boolean algebra number system for 1 or 2 days, 1 or 2 sessions. If that gets over, then we will go to K-maps. Then we will see miscellaneous problems in K-maps, 1 or 2 sessions. Then combination circuits, many are there in combination circuits, maybe 2, 3 sessions. Then sequential circuits, maybe 2, 3 sessions, like D to A to D converters, 2, 3 sessions. One session is sufficient for that. And the finally this static timing analysis, right? We have that setup time, hold time, all those things, all those mathematics, little bit. Okay, that also we will see in 1 or 2 sessions if you want a concept and all those things. Okay, which option, madam? M equal to C bar, N equal to B bar. Oh, you are saying no option is right. Mamata Singh. Okay. If you don't find any answer, you can say none. None of the above. This is by default will be there. Option E. Sorry? Sorry? I didn't explain anything, no. Oh, this is you solved already. Okay. Ah. Yes, I will do. I'll do. I'll do. No need to ask please and all. Okay. I will anyway solve. Okay. I'm just giving time for you guys to just do it. Okay. Don't worry. I'll solve it. Okay. So what is that they're saying? Boolean function is written as this, right? That means what? AB plus A bar C is equal to this one, right? That's what they are saying, right? Correct? No. That's what they meant by. If it is written like that. So you look at the right side. This is A multiply with A bar, I mean A and A bar plus A and N plus A bar and M with and Mn, right? In this, I would like to change the color. A into A bar is 0, all of you know. Then what is there here? An plus A bar M plus Mn, right? That is equal to AB plus A bar C. Now, can somebody say we can apply consensus here, right? Consensus. Just now we discussed, right? Just 15 minutes back. A P1 plus A bar P2 plus P1 P2. That means that I can just write A into N plus A bar into M. This is equal to AB plus A bar C. Now you can compare, no? What is N? N is B. What is M? M is C. So M is C, N is B. Option C is right answer. Hmm. Hmm. Why to do that, Amma? You want to, you can apply De Morgan's, but if you apply De Morgan's, you need to apply De Morgan's on both the sides, like this. What is the point of doing that? Unnecessary. Oh, okay, okay. Don't do that. Okay. Yes. Ah, ah. You didn't understand. ఏం అర్థం కాలేదు నీకు చెప్పు. Can I speak in English? I mean Telugu also in between because that guy seems to be speaking. Which one? This one? Yeah. So A dot, I just multiplied. Like you have this, no? A plus B into some C plus D. How do you do this? You multiply this with this, right? A and C. What do you do? This is A and B plus B and C plus B and D. That's all. That's what I did. Nothing else. Okay, boss. Thank you. Okay. Any other questions? Okay, great. By the way, how are the questions? Are you guys liking it? Say yes or no in the chat box. That's why miscellaneous, right? Not tough. These are basics. Because the basics are not proper, that's why it is looking like as if it is tough. Otherwise, it's same, no? Simple basics, right? Okay. Start practicing. I can help you. Like if you, I'll share my mail. Okay. In that mail, if you ask me, I can help you with the study materials. Okay. What are all you can study? Hmm? Uh, Handbook for basics. No, nothing as such. But what I can do is, if at all, if all of you ask me, let's say, one thing I can do is, if right now I can take a poll, like if you want me to teach one topic next session, for example, I can take up that topic and then teach next session. Whichever you feel that, sir, I want some basics here, I am just lacking here. Yes. And I have see, you can also mail me if you if at all. Do one thing, last 5-10 minutes I'll do a poll, right? You guys tell me any topic that yes. Hmm. This notes, this I will share it, no problem. You mail me, then I will share. Okay, great. Let's go to next problem. Last 5-10 minutes, please be there. I will just take a poll. If at all in these topics, whatever we discuss, let's say Boolean algebra and number systems. I think I didn't touch the number system yet. If you think that, sir, I need some more basics about it, I will teach in the next session. Okay, and then start with another things. Okay, all right. Yeah, next. And I'm telling you seriously, these are very easy. Okay, straightforward. X bar z plus z plus x bar plus z bar, x bar plus y plus z bar w. Can we reduce it? Sorry? Z into z, z into z is z square in Boolean algebra. Now, not in Boolean algebra. They are in ordinary algebra. In Boolean algebra, okay, you don't have squares, right? See, let's say, for example, a into a you want to do. Okay? You take a truth table. Hmm? Truth table you take. A, this is a dot a, right? So, you take 0. This is it doesn't matter whatever you're writing. You can write anything. Okay, a into a you can do, a into a bar you can do. Okay, so you take a equal to 1, 1 into 1. What is 0 into 0? 0. 1 and 1 is 1. Means that if you look at this, a and a is similar to a, right? Same, right? This is 0, this is 1. Exactly the same. So I can say a and a is a. This is the basics of Boolean algebra, right? Some of the similarly a plus a is a. Something like that. In ordinary algebra, a plus a is 2a. But Boolean algebra, a plus a is a. That's why it is very easy. Okay, any answers? No options for this. It's a numerical answer type. Yes. Any- Sorry, my video is on. No, what are you saying? Should I switch on the video? Okay. Where is this guy? Video guy. I don't know where it is. Okay. Last 10 minutes of now interaction we'll do. Okay. Let's not mess it up right now. Okay, right. So, anybody got the answer for this? Okay. Okay, somebody got 3. Now let's see this. See, something like this, a plus b into a plus c. I can write it as a plus bc, right? This we have seen in the previous slide, correct? This one, right? This part. So, if I look at this one, x bar plus z into x bar plus z bar, I can write it as x bar plus, in the place of b, z is there, in the place of c, z bar is there, right? Z and z bar, correct? So, what is z and z bar? 0, right? This is 0, right? So, these two results in x bar. Now, what is the left? X bar plus y plus z bar w, right? Now, this also I can write something like this. How? X bar plus 0, x bar plus y plus z bar w. Now, this again I can write it as a plus bc format. X bar plus 0 into x bar plus y plus z bar w. 0 into this is 0, right? Finally, what you got is x bar, right? You understood this? How many literals? I explained, sir, already. What you didn't understand? Okay. Which step you didn't understand? This one. Yeah. So, let's say this is the format, no? This is the law, okay? A plus B into A plus C can be written as A plus BC, right? So, here you treat this as A, this as B, again this as A, this as C, right? This can be written as A plus BC, right? So, I just got this. This step, similarly I wrote like that. X bar plus 0. See, A plus 0 is A. Just by adding 0, nothing is going to change, right? So, I did like this. Suppose if this is one of the step. Okay, this is very, very important. Like you can write like A into, right? A plus B is A. This is very, very important, identity in the Boolean algebra. So, if you think that this is little tricky, you can also try this, right? You multiply this x bar with x bar and x bar plus x bar and y. I can multiply with y and x bar with this x bar and z bar double. And we already know a into a is a. So x bar into x bar is x bar plus this is x bar y plus x bar z bar w. Now in this, if we observe, I can take x bar common everywhere. If I take x bar common everywhere, I'll get 1 plus y plus z bar w. So what is 1 plus anything in Boolean algebra is 1. Again, that is x bar. Now you see this answer really doesn't change. Okay. Now you take it. If whatever is easy for you, you can take it. So how many literals? 1 literal. Is that clear? Okay, great. Now let's go to number system. What is 7-bit? 2's complement representation of 43. Yes, Jayesh is right, Suraj is right, Samir right, great guy. Hey, I just shared my email ID in the chat box, srinivasb@iasc.ac.in. Please mail to me whatever the questions or doubts or anything else that you have. Yeah. Which option? Yes, yes, you are audible. Ah, okay. Sure, definitely. At the end. At the end. See, we are going with the flow. So first we will cover Boolean algebra and K-maps. I mean, like number systems. Then we'll move to K-maps. Then we'll move to combinational circuits, sequential circuits. At the end, setup time, hold time, all those things will be there. And setup time, hold time, I am going to teach the entire concept and then I'll solve the problems, right? So yeah, I know that that is little difficult is there in understanding, but that I'll make sure that that will be very easy for you. Okay. So great. Yeah. Okay, you can mute yourself. Who is this? Okay. Okay. So any answers? Somebody somebody said something. B or something. B for Bombay, D for Delhi. Oh, okay. C for Calcutta. Okay, fine. Okay, both are wrong. Don't worry. First of all, if you look at number systems, let's see. I don't know. I have to see a calculate. Number systems, you have something called positive numbers and you have something called negative numbers. And these two's complement and all, like whether it is sign magnitude form or one's complement form or two's complement form, These are only valid for negative numbers. Yeah. So, hey, you need to focus, man. I'm not going to explain again and again. So, sign magnitude form, 1's complement, 2's complement form are valid only for negative numbers. Okay. Positive numbers you can write as it is, whatever they are. So, if I take 43 and you know it is a positive number, right? You don't need to do all these operations of 1's complement, 2's complement, sign and all those, right? We know 43, you know, right? Like if I distributed 2 power 0, 2 power 1, 2 power 2, I'm just writing the weights 2 power 3, 2 power 4, 2 power 5, 2 power 6. This is 1, 2, 4, 8, 16, 32, 64. So 43, 1. Ah, great, great, no problem. 11 will be there, then 1, then what is left over? 0, 1, 1, 0, 1, 0, 1, 0, double 1. Which option? Option A. Great, you're right. But if they say, what is the negative, what is the 2's complement of representation of minus 43, then what you should do? First you, take first plus 43. First you here take this plus 43 representation 1, 1, right? You say you need these many bits, right? One is for the sign bit. Okay, this is for the sign, for example. Now you do 1's complement on this. Don't add directly, 1. 1's complement is just complement this. 1 is there, 0. 1 is there, 0. This is 1. This is 0. This is 1. This is 0. This is 1. Now you add 1 to this. Once you have taken 1's complement, 1, 0, 1, 0, 1, 0, 1. Right? If they ask minus 43, but if they ask 43, whatever you get it in a binary form will be the 1's complement form or 2's complement form or sign magnitude form. Okay. Am I clear? Huh. Sorry? I mean, you want to say plus 43 plus 1. No, no, don't do that. Okay. You have to do everything in binary. Binary, not in decimal. First you convert the number into binary, then you do this. 2's complement is what? 2's complement is, no, no, you will not get. See, the point is this. You take, no, I don't do all those things. Just this is very simple way of understanding, right? If you want to get 2's complement, take 1's complement, just add plus 1 to this. That's all. If you have, if you want to get 10's complement, take 9's complement, just plus 1. That's it. Okay, let's go to next question. And I'm just giving a hint. Okay, because anyway, next problems will be like that. Now you look at 43 plus 43. What is this? 0, 1, 0, 1, 0, double 1. What is minus 43? 1, 0, 1, 0, 1, 0, 1, right? Now, suppose you don't know about this. They just said that these are the 2's complement forms, let's say. And I'll ask you which is negative, which is positive. How do you identify? Look at this sign bit. Yeah, look at the sign bit. If this is 0, that means it is positive. You look at this, this is 1, that means that is negative. You understood? So I think we need to stop it right now. Uh, by the way, you guys want me to teach number systems, sign, ones, twos, complement, and all those things? I'll do it in next session. I have a lot of questions on that. See, so many questions are there. You want me to teach it? Audience poll. It's a democracy, right? So, okay, let me stop sharing it. Hmm. I shared already. Okay, I will share it again. Srinivas B at the rate iisc.ac.in. Okay. Okay, let me interact now. This is Srinivas here. A lot of beard and all those things. Don't make fun of it. So, uh, okay. Potala Gangadhar, you need to focus, right? So what we can do is if you want me to teach ones complement, two's complement, and sign magnitude, okay, I will teach in the next session. Like maybe quickly, I will teach like 15-20 minutes starting, and then we will go to the problems. Are you guys okay with that, or you want me to directly start solving the problems without any context? Okay. Samir, your voice is not audible, Samir. Okay, only some. I got only 7-8 hands. Okay, then I think next session, I'm just typing in the chat box. So we will start. I will teach you number systems followed by problem solving. Boolean algebra. What do you want in Boolean algebra? No, we have very limited session. No, we right now I guess 14 or 12 sessions are planned. So uh, what I can do is, anyways, I also understand. Actually, I have a lot of content in my mind just to share. So I want you guys to learn this and then just apply in the exam and then get it. You don't need to read also something. I want to make sure that you do like that. Okay, what I can do is uh, uh, next session, little bit of Boolean algebra you can touch upon, like duality, consensus, and basic laws and all those things. Then we will move to number systems and then do that. Okay, but quickly. But next time, you guys need to join sharp at 5 o'clock. I will start sharp at 5:02, 5:03. Sorry. Okay. Uh, hmm. Definitely no, because they that will be asked in but my expertise is in digital circuits, right? So this is only for digital circuits. Hmm. Yes, yes, yes. Huh. Yeah, yeah. So actually, Mamta, what I feel is, because people are asking it, I'll just touch upon next session, maybe for half an hour, and then start solving the problem, and then we wind up that number system and Boolean algebra. Once we move to K-maps and all, we'll try to spend a lot of time on the concepts. I will make sure that you know that counters, once you listen from me, it will be super easy for you. I'm not telling it with arrogance. I'm just telling you because I understood that's very simple to understand that. So we will spend a lot of time on the shift registers, problems, and all those things. Okay, we will have 2-3 sessions or more sessions for sequential circuits, and just move on. And finally, setup time, hold time, all those concepts we'll discuss in detail. I'll teach everything in detail. Yeah. Hmm. 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 Right. Right. Yeah. Hmm. Hmm. Definitely, these are all like 90% of the time they are all previous gate questions. Okay, like last 20 years, 25 years, 30 years, like some questions from IES 1 or 2. Okay, I just took it up so that your concept will be refined instead of explaining the entire concept. So definitely it will be useful. No problem. Hmm. Hmm. Like previous gate question solving. Uh, Theory, I'm not sure how they're functioning actually, but we are also preparing previous gate question ka solutions. Yeah, yeah, yeah. Okay, then Sangesh, you can open your mic and then you can ask what is that your doubt is. Sangesh, are you there? I think I have cleared his doubt, I guess. Okay. Hmm. Okay then. Thank you guys. If you don't have any questions, we can catch up next Tuesday, sharp 5 o'clock. Thank you. Bye bye. Bye bye. 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 Thank you. Bye bye.